Hey everyone, welcome back to the Physics Past Paper series. So today we're going to talk about the multiple choice paper 1 from the October-November 2024 variant 1-3. In the previous 2 days, last 2 days, we have discussed 1-1 and 1-2. Today we're going to 1-3. All right, so let's see. Before we actually start with this, I wanted to introduce to you, I think some of you may have seen this in the videos. This is part of the full grade booster pack, which I will show you just in a minute that where it's available on Patreon. This is part of the full A-level grade booster pack. This particular document contains everything that you will need to ace the AS paper 1 at least. For paper 2, there's an additional document that is the frequently examined questions that focuses on the theory questions. For AS and A2, we have separate docs for derivations also and for graphs also. And this is available on our Patreon page. So the link will be given in the description. So all you have to do is to go and check this out. It contains frequently examined questions, definitions and formulae, derivations, graphs, everything you need for A-levels. Graphs for now, only the A2 ones are included, but the derivations, definitions and formulae, frequently examined questions, even if you're watching this at a later date and maybe are applying for an October, November 2025 or 2026, for example, these will be immensely helpful. So now let's see how we can actually do this. Which statement about physical quantities is correct? So just to show you how you can actually use this, let's see how for the first two questions we can do that. So we go back to over here, physical quantities. All physical quantities consist of a numerical magnitude and a unit. So this is true for straightforward answer over here. So which one of these? Yeah, the last one. Must always have a magnitude and a unit. What is the reasonable estimate of a mass of a solid sphere of copper that has a diameter of 60 centimeters? So using the diameter, we can figure out the volume, 4 over 3 pi r cubed. But we do not have is the density. Again, we go over here, scroll down a little bit over here to reasonable estimates table. You look at the density, there is copper over here, roughly about 8960 kg per meter cube. That's all we need over here. So even if this should be a reasonable estimate over here. So even if you go with 9,000 over here, this is fine. So not a very big deal. So let's go with 9,000. So let's say this is 9,000, approximately equal to 9,000 kg per meter cube. So when we find out the mass, that is rho and v, we plug this into the calculator. So density 9,000 times by 4 pi divided by 3 times by, now diameter is 60 centimeters, r would be 0.3 or 30 centimeter or 0.3 meters. So 0.3 cubed. So we get about 1017 roughly. So 1017.8, let's say, kgs. So reasonable estimate would be 1000. The power output P of a star can be modeled with this equation, where sigma is a constant, A is the surface area of the star, and T is the surface temperature of the star. What are the SI units of sigma? All right. So power is in watts, but in base units, since we need base minutes, that would be energy per unit time. So energy is kg F times by S, same unit as force times by distance. So kg meter squared S minus 2. And since we have divided by time also, force divided by, energy divided by time, so you make it into -3, and we do this over here. Now that's P. A is meter cubed. Sorry, cross. Wait, sorry. A is the surface area, so that's meter squared. And T is in kelvins. So T is in kelvins. All right. Now that we need sigma, that is P over A T raised to power 4. So that would be kg meter squared second per second cubed, and then you have meter squared times by k raised to power 4. So meter squared and meter squared get cancelled, leaving us with simply kg Kelvin raised to power 4 and per second cubed. So that is second cube minus 4. Sorry, that's also minus 4. Okay. That is going to be B part. A boy throws a stone with a horizontal velocity of 10 meters per second from the top of the building. The height of the building is 8 meters. Stone travels a curved path until it hits the horizontal ground as shown. Air resistance is negligible. How long does it take for the stone to reach the ground? Okay, so for that we just need to look at the vertical displacement. So for the vertical displacement, uy is equal to 0. And the vertical distance sy that has covered is, sorry, 8 meters over here, as written over here. So sy is equal to ut uyt plus half at squared, and that is also ay. So sy is 8, since it is thrown with a horizontal velocity, so initial vertical velocity is 0. Then we have half. You can apply g over here, that is 9.81, and t squared, that is what we are trying to find out. So 2 times by 8 divided by 9.81, and then we take the square root of the final answer, that is 1.27, that is 1.3. Simple, straightforward. Okay, so let's see. 4 cuboids with identical lengths, breadths, and heights are immersed in water. So basically this means identical volume. Volumes are constant. The cuboids are held at the same depth and in identical orientations by vertical rods. That means if they're all at the same depth and if they're submerged completely inside, they all have the same upthrust, since the volume displaced by these cuboids would be the same. Water has density rho. What cuboid is made of material of density 4 rho. X is made of 2 rho. Cube Y is made up of density rho. Z is made up of density 0.5 rho. Which statement is correct? Upthrust of the water on each of the cuboids is the same. That is correct. We already said that, because upthrust depends on rho g v, and v is the volume displaced. So since they are at the same depth, same orientation, so upthrust would be the same. So that would be straightforward A. We don't even have to look at the rest. In which example it is not possible for the underlying object to be in equilibrium? For in equilibrium, we need resultant force to be 0 and resultant moment about any point to be 0. So airplane climbs at a steady rate. So, okay, we'll come back to that. Airplane tows a glider at a constant altitude. No. Speedboat changes direction at a constant speed. Okay, I think this is the C one, but let's see. 2 boats tow a ship into the harbor. Okay, so if we look at this, aeroplane, when it's climbing, sorry, this is an airplane, for example, over here. This is a very like poor diagram, but it has weight over here and lift upwards. So if it is climbing at a steady rate, that means the lift and weight are balanced. Otherwise, it would not be steady rate. Aeroplane tows a glider at a constant altitude. Again, there's glider is being towed. There's going to be tension. It does not say constant speed. It's saying constant altitude. So it's towing the glider at a constant altitude. That means again that the lift and weight are the same. Speedboat changes direction at a constant speed. So changes direction at a constant speed. That means one very beautiful example of this is the circular motion. So changing direction at a constant speed. The speed can be constant, but since it is changing direction, velocity is changing direction. And if velocity is changing, the body is accelerating. Two boats tow a ship into the harbor. Both of those could be moving at a constant speed, straight direction. So could be in equilibrium also. So for this, it is not possible. Now, two identical balls are projected vertically upwards from ground level with the same initial velocity. Ball X is in a vacuum, ball Y is in the air. So ball Y will face a little bit of drag force. Which statement about the motion of the balls is correct? Ball X reaches greater maximum height and in a longer time than ball Y. And okay, we'll come back to that. I think this is going to be true. Ball X reaches a greater maximum height. We already know that its ball X is going to be reaching a maximum height, a greater maximum height because it's in a vacuum. It's a lower drag force. So as we can see, this is true for all of them. However, ball Y, now ball Y, if this is ball X, for example, ball Y will not only achieve the maximum height uh, earlier, it's like a shorter maximum height, but obviously that would also mean that it's in less time also. So both are under the same gravity. They both are undergoing minus g for the vertical motion over here. So if it is achieving maximum height before, so obviously the time for y is less also. So straightforward. The graph shows the variation of velocity with time t for a stone that falls from a bridge into a lake and sinks to the bottom of the lake. Falls from a bridge into a lake and then sinks to the bottom of the lake. What can be deduced about the motion of the stone? Okay, so over here, if we notice over here, the velocity is decreasing, the object is decelerating. However, at this point, we can say that the stone has fallen into the lake. Velocity very quickly decreases, and then it continues with an almost constant velocity to the bottom of the lake. So terminal velocity was reached in the air? No, because had the terminal velocity been reached, we would have a constant over here. Terminal velocity is reached inside the lake. So let's continue. Acceleration in the air was decreasing with increasing time. That we already discussed because the gradient is decreasing, acceleration is decreasing. So this is correct, but let's check the idea. There's also distance traveled in water was greater than the distance traveled in air. That's not true. Rate of change of velocity in air was constant. Rate of change of velocity is acceleration, and acceleration, as you can see, gradient is not constant, so obviously that's not true. B is the correct one. The graph shows the variation of momentum p with time t for a car. What is the resultant force on the car at t is equal to 10 seconds? So at 10 seconds over here, we need to know uh, the rate of change of momentum. So at this point over here, we can figure out the rate of change of momentum. We just need the gradient of the uh, we don't we gradient of the graph at this point over here. So gradient is going to be 4 minus 1 divided by, sorry, this is 10 raised to power 4 also. divided by 20 minus 0. 20 minus 0. So 3 or 30,000, 3 times by 10 raised to the power 4, 30,000 divided by 20. So that is 1.5 10 raised to the power 3, which would be 1500. So 9b. Two objects x and y form an isolated system. X and y collide and then separate. The mass of an x is greater than the mass of y. So mx is greater than mass 1. Which statement about the collision is correct? Change in momentum of y is greater than the change in momentum of x. This is not true because the change in momentum for x would be the same as change in momentum for y. Force on y is greater than the force of x. That is also not true because if we divide this on both sides, we will get force is equal to force. Negative, one of these will be in opposite direction but equal. This is also not true. Forces x and y exert on each other act for the same length of time. That is true. Forces x and y exert on each other are gravitational forces only. No, not necessarily. Actually, no. There's a contact forces. So C is correct. Which row states whether the total momentum and total kinetic energy are conserved in inelastic collision when there are no external forces? So in inelastic collision, total momentum is conserved. That means these two cancel right away. But total kinetic energy is not conserved. So B is the straight answer. Correct answer, sorry. A tennis ball is thrown vertically upwards. Tennis ball reaches its highest point and then falls back to the point from which it is thrown. That means net displacement 0. Air resistance is significant. That means the is going to be deceleration. Drag force. At which position on the path of the tennis ball is the resultant force on the tennis greatest? At the start, after the tennis ball is released. Okay, so we are talking about the resultant force. So we are talking about vertically upwards motion. We know that it is thrown upwards, u. Over here, the velocity is 0, and it's coming back with the same velocity because obviously it's coming back at the same point. But however, the air resistance is significant. Ideally, this would be the case, but since air resistance is significant, that's not practically going to happen. So due to the drag force over here, as soon as it accelerates, the drag force will reduce the resultant force. Same case over here. The object is moving in the air, drag force will slow it down, decrease the resultant force. So logically, this would be the starting point where there is absolutely no drag force. So this would be the point where the resultant force on it would be just the weight of the object. There's no drag force. So at the start after which tennis ball is released, then this is the correct answer. Which statement correctly describes a couple? Couple is a pair of forces that act in the same direction. No, they are equal, separated by some distance, and in opposite directions. Couple is a pair of forces that act on the center of gravity of an object. No. Couple is a pair of forces that act to produce a resultant force. No, because the forces are in opposite directions, so no resultant force. Produce rotation only. So yes, it's a pure rotation. Because when you have this kind of thing, the net force in either direction is 0 because both forces are in opposite directions. However, since they are about a pivot or a center point, whatever you want to call it, it produces pure rotation. So D part. A uniform beam of mass 1.4 kg is pivoted at P. The beam has length 0.6 meters and P is a distance 0.2 meters from one end. Loads of 3 and 6 kgs are suspended at distances of 3.5 and 1.5 meters from the pivot. Okay. What is the torque that must be applied to the beam in order to maintain it in equilibrium? So notice that the question is that the torque must be applied on the beam. They're not asking about some force. They're not asking us to place some mass on this. They're just simply asking what torque must be applied. So basically we need to find out what is the difference between the anti-clockwise and the clockwise moment over here. So counterclockwise moment about P, that is going to be, sorry, counterclockwise would be this one and this one, right? So if P is 0.40 over here, um, that would mean this is at 0.3 meters and this distance is 0.1. Right, so the weight is at 1.4 g times by 0.1, 1.4 g, and this is 0.35 meters times by 3g. Clockwise, now clockwise is just this one, that is just 0.15 times by 6g. Now we just need to find out the difference between them. So 1.4 times by 0.1, 0.14, plus both have g, so we don't have to worry about that. 3.5 times by 3, so 1.19 g. And this one is 0.15 times by 6, 0.9. So difference is 1.19 g minus 0.9 g, which again we can calculate 1.19 minus 0.9, 0.29, and then times by 9.8. So that is 2.84. That is going to be D part. The diagram shows three rigid objects, P, Q, and R, being subjected to different combinations of forces. Which objects are in equilibrium? So equilibrium again requires resultant force being equal to 0 and resultant moment about any point to be 0. So if we take note, the 20 minus 10 over here will result in 10, and 20 minus 10 would result in 10 over here. So these 10 Newton forces are separated by some distance, so they will cause a couple. So if we see this over here, this 20 minus 10 parallel force will result in 10 Newton force in this direction. And this 20 minus 10 would result in 10 Newton force in this direction. However, these two forces are separated by some distance. They're equal opposite forces, but separated by a distance. So this will cause a rotation of the object, pure rotation of this object, or a couple about the center point over here. So obviously not in equilibrium. If we notice over here, in any direction we look at it, so if we look at it in the plane of these forces over here, so 80 minus 60, there will be a force 20 Newton in this direction, 80 minus 60, 20 Newton force in this direction. So obviously there is a resultant force going in this direction. We don't need to find it, we just need to know whether it's resulting in a non-zero resultant force or non-zero. So obviously again, this is not in equilibrium. Similarly, this one, we know 50 sine 30 is just 25 because sine 30 is half. This is also 25, so 25, 25, 50 in total. So 50 upwards, 100 downwards. So again, this is not in equilibrium. P, so none of them are in equilibrium, so that would be D. Okay. The diagram shows two liquids labeled P and Q that do not mix. The liquids are in equilibrium in an open tube. Three distances are labeled. What is the ratio of density of P and density of Q? So we remember from the manometers over here that the pressure at each level is the same. So this means that the pressure due to the depth of this liquid over here, 2x depth of this liquid, is going to be the same as the pressure due to this x depth of liquid Q. So uh, rho GH, GH is going to be 2x. This is rho, let's call it P. And over here, rho Q, G, X. So pressures are same. So rho P, G, 2x equals to rho Q, G, X. So canceling out some common factors, Gx, Gx. So rho Q over, oh sorry, we need density of P. So rho P over rho Q is 1 over 2. So 16 is A. A stone of mass 0.30 kgs is thrown vertically downwards with a speed of 20 meters per second from a height of 12 meters above the ground. It falls vertically until it hits the ground. Air resistance is negligible. What is the kinetic energy of the stone just before it hits the ground? So first off, we need to figure out what's the velocity. So V is equal to, V squared minus U squared is equal to 2AS. V squared is what we are trying to find out. 2 times by A is 10. Sorry, 9.81. 9.81. Distance fallen is 12 plus speed was 20 squared. Okay. So V square root of 2 times by 9.81 times by 12 plus 20 squared is 400. So this is the V over here, 25.207. So V squared, oh sorry, we didn't need that. So squared answer, that is 635.44. Right, okay. We need kinetic energy, so half mv squared. So this times by 0.5 times by mass 0.3. So that is 95. So that is D part. A student can run or walk up the stairs to her classroom. Which statement describes the power required and the gravitational potential energy gained while running up the stairs compared to walking up to them? So whether she is running up the stairs or walking up the stairs, the gravitational potential energy change or gained is going to be the same. However, power required for running will be more because obviously running is more extraneous exercise. Running provides the same gravitational potential energy, so these two cancel, uses more power. So obviously common sense, 18C. A weight W hangs from a trolley that runs along a rail. The trolley moves horizontally through a distance P and simultaneously raises the weight through a height Q. As a result, weight moves through a distance r from x to y. It starts and finishes at rest. How much work is done on the weight during this process? So since this is starting at finishing it at rest, so that means kinetic energy at this point is 0, kinetic energy at this point is 0. That means the only thing that's changing is the mgh or EP. So that would be just mgh. Mg is already given as weight, height is given as q, so wq is c. The equation for the kinetic energy ek can be derived using equations of motion. So 4 equations relating to the motion are listed. This force is equal to ma. Okay. So remember this. This is in the derivations one. Let me open it. So this is also present in the same grade booster pack on Patreon. If we look at the kinetic energy, change in, okay, so let's see this. So we need the kinetic energy, right? So if you notice, force is equal to ma. A we are getting from the 2as v squared minus u squared, and then we are multiplying by displacement to use the work or the change in work or the work done formula over here. So 3 equations we are using. F is equal to ma, 2as is equal to v squared minus u squared, and w is equal to fs or fd, whatever the question is saying. So we have this one, this one, this one. So 1, 2, and 3. That is the simple answer. So A part is correct. The force extension graph of a metal wire is shown. At which point does the metal wire stop obeying Hooke's law? So Hooke's law is the linear region basically. So A is where the straight, it's no longer a straight line. So that is the A limit of proportionality, and this is where the Hooke's law stops. A uniform wire is made of a metal that has Young's modulus of 1.3 10 raised to power 11 pascals. Wire is 2.54 meter long and a spring constant of this. What is the volume of the wire? Okay, so Young modulus is stress over strain, stress over strain. Wait. So stress is force over area, and strain is extension over the original length. So force is not given, but we know that force is equal to K times by extension. And we know volume is cross-sectional area times by length. So that's what we need over here. So once we rearrange this, we have F over A times by L over X. So F is Kx, as we said. L as it is. A can be written as V over L. So V over L, that means L goes over here and times by X over here, which again cancels out with this. So KL squared over V, that's what we need. K is 2.7 times 10 raised to power 4. L is 2.4 meters squared and divided by the volume. Actually, that's what we're trying to find out, no? Sorry. So Young modulus. So this is equal to Young modulus. So we need to divide by Young modulus over here. So we divide by Young modulus. That is going to be 1.3 times 10 raised to power minus 11, because it's going to be in the denominator this time. So V would be KL squared over E over here. So this is going to be this. We need this in standard form. 1.196, 10 raised to power 6. So I think that is going to be the D part over here, 1.2. Yes. A rubber cord hangs from a rigid support. The weight is attached to its lower end, is gradually increased from 0 and gradually reduced to 0. Force extension curve for contraction is below the force extension curve for stretching. Okay. What does the shaded area between the curves represent? That represents the energy lost or the thermal energy dissipated, because that represents the energy that is not recovered. So that is going to be thermal energy dissipated, because that's the one that's lost. A source of sound waves of constant frequency is traveling as shown. In which situation would the stationary observer detect a sound with the lowest frequency? To have a lower observed frequency, the object has to be receding from the object. And lowest would require more speed, because for the observed frequency we have v over v plus s, sorry, vs f basically. So more speed would mean that the denominator becomes higher, entire fraction becomes smaller, that means lower fraction or lower percentage of the original frequency. So low, we need receding, so that means this cancels out, this cancels out, and more speed between 5 and 10, that is D. Okay. So each of these principal radiations of the electromagnetic spectrum has a range of wavelengths. Which wavelength is correctly linked to its radiation? Gamma ray is microwave, ultraviolet, X-rays. Correctly linked. Correctly linked. So I think we can see this over here. That will also show you how this is going to work. So we go, sorry, my bad, in the waves topic, and we need to see where these are basically. So wavelength ranges over here. Let's look at 10 minus 9, 10 minus 9. Gamma ray is less than 10 raised to the power minus 1, so that means even smaller, so no. X-rays is in between minus 8 and minus 11, so minus 9 would be included, minus 9, minus 10. So no, that is also no. Microwave and ultraviolet, let's see. So microwave is in between minus 1 and minus 3, so minus 2 would be included. So again, microwave 1 is also not correct. But this one, ultraviolet, the option for the ultraviolet is minus 8. So as you can see, minus 7, minus 8 is included. So yes, ultraviolet 1 is correct. A transverse water wave has a frequency of 15 Hertz and a wavelength of 0.12 meters and amplitude of 4 millimeters. P is a water particle that is initially at peak of the wave as shown. What is the total vertical distance traveled by P in a time of 0.5 seconds? Okay, so basically we need to figure out what is the time period. So time is 1 over 15, 1 divided by 15. This is this value. And if we want to figure out how many cycles are we having in 0.5 seconds, so 0.5 divided by answer, so that is 7.5 waves. So in one complete wave, it goes 4 millimeters. No, sorry, 8 millimeters. Peak to peak is 8. Peak to peak is 8 millimeters. So total vertical distance traveled, not the displacement. So 7 peak to peak, so 7 times by wait a second. So if one cycle goes from this to this, so in one cycle, the distance that is covering one cycle or one wave is covering 16 millimeter. So in 7 waves, you are getting 7 times by 16 millimeters. And then 7.5 would be 7.5 also. 7.5 times by 16. So times by 16, that would be 120. So that is C. A wave is formed on a string. The student plots a graph of the variation with displacement d with time t for a point on the string. Student marks 2 points x and y. Which property of the wave is represented by the distance along the horizontal axis between x and y? This is displacement with time graph over here. So these points over here will tell us the time period. If this was displacement distance graph, this would tell us the wavelength. So period is the correct answer. A stationary wave is set up in a stretched spring. Which distance is equal to the wavelength of the wave? Double the distance between adjacent nodes. So between adjacent nodes is half the wavelength. That means when we have node to node to node, then we will have half. Half the distance between adjacent nodes equal to the wavelength. No. Half, we already said that between adjacent nodes is half the wavelength, but half the distance, no. It would be double the distance of between nodes. Distance between adjacent antinodes, no. That would also be lambda by 2. Distance between a node and an adjacent antinode, no. Oh, sorry, I didn't see the first one. Double the distance between adjacent antinodes. Yes, so this would be when you times by 2 over here, you would be equal to wavelength. So yes, 28A. A source of coherent light is incident on two slits, P and Q, which are placed 80 millimeter apart. The light has a single frequency of 1.5 10 raised to power 12 hertz. Light from a slit meet on the screen, that is the distance of 4 meters from the slits. Screen is parallel to the line joining the slits. Intensity sensor is placed on the screen at the midpoint of the interference pattern such that intensity reading is maximum. So this is the central maximum. Intensity sensor is moved along the string. Sensor travels through two intensity minima, two intensity maxima, and stops in the middle of third intensity minima. Which distance does the sensor move through? So two intensity minima. So this is constructive, destructive, constructive, destructive, constructive, destructive. So two intensity minima, two intensity maxima. So 1, 2, 3, 4, and stops in the middle of third intensity minima. 1, 2, 3. So somewhere over here, this is where it stops. Which distance does the sensor move through? Okay, so we need basically this distance over here. So we know from the formula over here, fringe spacing, x is equal to lambda d over a. So where a is the slit separation. So, and fringe spacing is between two constructive maxima, or sorry, like maxima, two maxima or two minima. That's what this is. So we need to figure out how much it's moving. So first off, we need the fringe spacing, and then we will see what distance is it. So lambda is 1.5. No, sorry, this is frequency. Okay. So c over lambda, 10 raised to power 8 divided by frequency 1.5, 10 raised to power 12. Distance is 4 meters. Slit separation is 80 millimeters, so 80 10 raised to power minus 3. So fringe separation is this: 3 times by 4 divided by 1.5 divided by 80 times by 10 raised to power 8 minus 12 plus 3. So 1 raised to power minus 2, which is 0.02. Sorry, 0.01. Right, okay. This is going to be in meters. Now, we need to figure out, this is fringe separation. So this is 0.01, this is 0.01, and this would be half of 0.01. So 2 times by 0.01 plus half of 0.01. So that is going to be 20, this 0.025 meters. When you multiply this by 1000, you get millimeters. So that is C 25 millimeters. A vibrating bar produces surface water waves in a ripple time. The wavelength of the waves is 5 centimeters and they pass through a gap of 20 centimeters. Which change will increase the amount of diffraction that is observed? We know that when the wavelength is in the order of the slit spacing or the obstruction or the width, the gap, then the diffraction is increased. So decreasing, okay, wait, so decreasing the distance between the bar and the gap? No. Decreasing the frequency of the wave. So, okay, so if we decrease the frequency of the wave, we know speed is going to be the same, f lambda. If we decrease the frequency, wavelength will increase. So that's what we need. We need the wavelength to be close to this order over here. So 20 centimeters. So amplitude reduction increase doesn't do anything, increase the width of the gap will further aggravate the problem. So increasing the wavelength by decreasing the frequency, that is the correct answer. What is an electric current? Rate of flow of charge carriers. So that is A. A wire of diameter D is connected to an electric circuit. There is a current I in the wire and the charge carriers have an average drift speed V. I is equal to NAQV. The wire is replaced by a new wire of the same material but with the diameter 0.5 D. That means if this was pi d squared over 4, now the new wire has cross-section area pi 0.5 d whole squared over 4. The current is adjusted so that the charge carriers in the new wire have an average drift speed 3v. So 3v over here. Okay, what is the current in the new wire? Okay, so previously you had N. Same material means that the N is the same over here. Q is the same, obviously for the same reason, because we're talking about the charge carriers. So only thing that's changing is A and B. So A1, V1 over, so let's go with I2, I1, A1, V1. So when we try to do this, you have pi and 4 will get cancelled. So A2 over A1, this is A2, this is your A1. You are going to be left with 0.5 d whole squared over 2 d squared. Now, drift speed this time is 3v. Previously it was v. And this is equal to the current I2 and I1. That is what we are trying to find out. So V and V get cancelled. D squared cancels out with D over here. So that the answer is 3 times by 0.5 squared, 0.75. So that is going to be 0.5. So I2 is going to be 0.75 I1. That is going to be A. A fixed resistor and a diode are combined by connecting them in series. Total potential difference across the combination is varied and corresponding current I is measured. Which graph could represent the variation of I with V? Okay, so for the diode, the current actually starts after a threshold value, after a threshold voltage has been achieved. So obviously that would mean that that would be the same case if it is connected in series with the resistor. So A is the one that is the correct one. The potential difference PD across a fixed resistor is V. But power dissipated in the resistor is 5 watt. Potential difference across the resistor then changes to a new value. With the potential difference, the energy transferred to the resistor in a time of 2.25 seconds is 45 joules. What is the new potential difference across the resistor? Okay, so power is V squared over R. That is what we are trying to find out. So R is the same over here. So P2 is equal to V2 squared over P1 over V1 squared. So V1 is basically just V. And okay, so power 1 is 5 watt. Power 2 is energy over time, so 2.25 divided by 40. Sorry, no, it's the other way around. 45 divided by 2.25, that is 20. Previously, this is V squared, and now we need the V2 squared. So V 2 squared is 4 times by V squared. So V2 is 2 times by V. So 34 is B. Okay. The diagram shows part of the circuit that uses a potentiometer wire to measure a potential difference in an external circuit. Potentiometer wire XZ has length L1. It is connected to a cell of known electromotive force E that has negligible internal resistance. Terminals P and Q are connected to an external PD being measured. The length of the potentiometer wire being between points X and Y is L2. Ratio of lengths L1 and L2 is used to determine the potential difference between P and Q in terms of E. Which condition must be met in order to determine this PD? So the condition. Oh, the condition is that when we are actually working through this, wait. Now the condition over here, if we notice current I1 must be 0, obviously no. I2 must be 0. This is correct over here. Because if there is current flowing over here, there is a path to flow over here. So even if this is a short circuit, that means current would bypass over here. If there is some other kind of resistant over here, maybe a resistor over here, or let's say we model this with a resistor. So that means the net resistance across XY could be different, which would alter the potential difference across XY. So we need the I2 to be 0 over here. So B is correct. All right. The diagram shows a circuit. Which statement about the circuit is not correct? So let's see over here. This is a switch. This is a lamp, voltmeter, internal resistance, EMF. Electromotive force is the energy transferred per unit charge. No, that is correct. Energy transferred from chemical potential energy in the cell to other forms when the switch is closed. That is the definition of an EMF also. The electromotive force of the cell is greater than the terminal potential difference when the switch is closed. We already know this, that the EMF is going to be equal to terminal PD plus lost volts. So EMF is greater than the terminal PD. We already know this. So that means the fourth option is correct. When switch is open, the voltmeter measures the electromotive force of the cell. That is the one that is not correct because the voltmeter is measuring the terminal PD. A circuit contains a battery of electromotive force E and internal resistance R connected to two resistors, each of resistance 2.5 ohms. The current in one of the resistors is 0.8 ampere. Which expression where E is in volts, R is in ohms gives the internal resistance R? So if we know that the terminal potential difference across 2.5 would be the same. That means the current flowing through this is also going to be 0.80 amps. So which means that the current that flowing through the circuit is 1.6 amps. So that would mean that the E is equal to I times by net resistance, that is R plus these two, which is let's find out. So 1 divided by 2 divided by 2.5, because 1 divided by 2.5, 1 divided by 2.5, that is 1.25. So we need R over here, so we can isolate R. So E over I, so I is 1.6, so 1.6 R plus 1.6 times by 1.25, that is 2. That is E. So R would be E minus 2 divided by 1.6. E minus 2 divided by 1.6 is C. Now, what is the rest mass of a beta particle? So rest mass of a beta particle is an electron or a positron. It has this thing over here. You can just see that over here. This is the 1 atomic mass unit. What is the name of the group class of particles containing mesons, and the name of the group of the class of particles containing baryons? Both of those are classes of hadrons, so 39 is A. A magnesium nucleus 2312 decays by emitting two particles. The resulting nucleus is sodium 2311. Which two particles are emitted? Okay, so we can see this over here that the proton number is decreased by 1. So that only happens when proton decays into a neutron plus a beta plus particle and an neutrino, electron neutrino. So that is the beta plus decay. So that's D part. All right, so that is the end of this paper. Hope you understood or learned a little bit about how to solve these equations. So for not all of these equations, we will actually have to work out the math. Most of the times we have to use a little bit of process of elimination and a little bit of common sense and process of elimination. I think I've already said that. Okay, sorry, my bad. So yes, that is the end of this paper. Hopefully in the next video we will look at another paper. Meanwhile, if you have any problems, if you have any confusions, do reach out. If you want some help preparing for the exam, do reach out on us on WhatsApp. It's given in the link tree link over here. You can find the WhatsApp link over here. You can reach us out through email also, absolutely fine with that. If you think I made a mistake over here, also feel free to point out. And yeah, see you in the next video. Bye bye.